Good evening, children.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening, children. All right. So today we'll take the introduction to this chapter, areas related to circles. So the term sector related to a circle is not new to you. Sector. Okay. So a sector, how do you define a sector? A sector is a region. A sector is a region bounded by two radii and an arc. All right. So circle, center. Now this region is called a sector. Now let's name it. The center of the circle O, this point on the circumference A, this point on the circumference B. And you can take any point, in between this arc AB. So you can just mark off a point like this C. So now this shaded region is named or called sector OABC. Sector OACB, not BC, sorry, OACB. OACB. The shaded region is a sector OACB. Now you can see that the sector is bounded by two radii, OA and OB. OA radius, OB radius, and an arc ACB. So the enclosed region is called the sector, and the sector is contained between two radii and one arc. So radius OA, radius OB, and arc ACB. Radius OA, radius OB, and arc ACB. Now, so this is the sector. Now the angle subtended at the center, the angle subtended by this arc ACB at the center is called the sector angle, normally represented by theta. The sector angle, or it is angle AOB, sector angle. Sector angle is angle AOB. Okay, normally called theta. Angle AOB is the angle subtended by arc ACB at the center. And this angle AOB is called the sector angle. Now we are interested in finding the area of the sector. So we know that the area of a circle is pi r square. The area of a circle is pi r square. And we also know that this sector is a part of the circle. The sector is a part of the circle. So the area of the sector is some fraction of the area of the circle. See, like if the total strength of the class is 30, girls and boys are a part of the class. So some fraction of the class are boys and the remaining or another fraction of the class represents girls. Now let's say that 2/5 of the class are boys, then 3/5 are girls. So how do you find the number of boys and girls? So if 2/5, I don't know what I said. So if 2/5 are girls, so 2/5 into 30. If 2/5 of the class are girls, this fraction 2 by 5 represents the fraction of the girls in the class. So how do you find the number of girls in the class? So 2 by 5, that fraction into the total, into the total number of students. So 2 by 5 into 30. So there are 12 girls in the class. 3/5 of the class are boys. So 3 by 5 into 30. This fraction of the class are boys. So 3 by 5 into 30. 18. So the class has 12 girls and 18 boys. In the same way, the sector is some fraction. The area occupied by the sector is a fraction of the whole circle. The area of the sector cannot be more than the area of the circle. The area of the sector is definitely less than the area of the circle. It is some fraction of the area of the circle. So how do you find that fraction? Like how we understand, or like how we express 2/5 of the class are girls, 3/5 of the class are boys. So what fraction of the circle is the sector? That fraction is what we have to find. And that fraction is the sector angle theta divided by the complete angle around that point O, 360 degrees. Theta by 360 is that fraction. The question is, what fraction of the circle is occupied by the sector? How do you find the fraction of the circle occupied by the sector? So to find that fraction, the total, the denominator is 360. Okay, because we are talking about the angle around this point O. The angle around this point O is 360 degrees. And what is this angle, the sector angle? Theta. So theta by 360 is the fraction. So supposing the sector angle is, say, 60 degrees. Okay, we'll just assume that the sector angle is 60 degrees. This one is 60 degrees. So 60 by 360. 60 by 360. And what is 60 by 360? 1 by 6. 60 by 360 is 1 by 6. So if the sector angle is 60 degrees, that means the sector occupies 1/6 of the area of the circle. If the sector angle is, say, 90 degrees, the sector angle is 90 degrees. So 90 out of 360. 91s are 94s are 1 by 4. So that means the sector occupies 1/4 of the area of the full circle. If the sector angle is 40 degrees, the sector angle is 40 degrees. 40 out of 360. 1 by 9. So that means that sector occupies 1/9 of the area of the full circle. So now how to find the area of the sector? That fraction into pi r square, like how we did 2 by 5 or 3 by 5 into the total number of students, 30. In the same way, the fraction into the total area. You want to find the area of the sector, right? So the fraction into the total area, like the fraction into the total number of students in the class. In the same way, that fraction into the total area. So the fraction is theta by 360 into the total area of the circle is pi r square. So this is the formula to find the area of a sector whose sector angle is theta. This is the formula to find the area of a sector whose sector angle is theta. Theta by 360, the sector angle. You want to find the area of a particular sector, so you should know the sector angle. That sector angle divided by 360, the total, the complete angle around the point O. This is the fraction into the total area, pi r squared. So area of the sector is given by the formula theta by 360 into pi r squared. Area of sector is equal to theta by 360 into pi r squared. Square units. Now again, a sector is a region bounded by 2 radii and 1 arc. So it's a closed figure. A sector is a closed figure. And the perimeter of the sector will be the length of the radius 2 times. R plus R plus L. L is the length of this arc. L is the length of this arc. R plus R plus L will give you the perimeter of the sector. Okay. Write down this, children. Quickly make a note of this. Done, children?
Yes, ma'am.
Yeah. All right. Make a note of the formula. Area of sector is equal to theta by 360 into pi r square. Okay. So the next thing we have to understand is how to find the length of the arc, which is a part of the circle. How do we find the length of this arc? How do we find the length of this arc, which is a part of the sector? I said circle, I think earlier, I'm sorry. How do you find the length of the arc here, which is a part of the sector? Of course, it is a part of the circle. So now this part of the circle is a part of the sector. So how do you find the length of this arc? So like we understood the formula to find the area of a sector, the length of the boundary of a circle is 2 pi r. The length of the boundary of the circle is 2 pi r. Now, this arc is a part of the full boundary. This arc is a part of the circumference of the circle. So the length of this one will be some fraction of 2 pi r. The length of this arc is definitely less than the value of 2 pi r, because 2 pi r is the total length of the circle. So the length of this piece or the length of this arc will be less than the circumference of the circle. And it is some fraction of 2 pi r, because 2 pi r represents the whole thing. Like the number of students 30, here 2 pi r represents the total value, the total length of the boundary of the circle. So the length of this arc will be some fraction of 2 pi r. So what fraction of 2 pi r? Theta by 360 into 2 pi r. When you have to find the length of the arc The arc is a part of the circumference. So it is the fraction into 2 pi r. When you have to find the area of the sector, sector is a part of the area of the circle, right? So area of circle is pi r square. So some fraction of pi r square. Area is fraction into pi r square. Length of arc is the same fraction. The same fraction into 2 pi r. Because arc is a part of the boundary. So length of arc ACB. This is how it's written symbolically. Arc ACB or arc ACB. All right. So length of arc ACB or simply arc AB. Simply arc AB or ACB is equal to theta by 360 into the total length of the boundary, 2 pi r. And this is length, so not square units, units. Length is one dimensional, length of arc. So it's not square units, it's not area, units. Theta by 360 into 2 pi r units. Yeah, make a note, children. Then children, perimeter, I don't think I have to explain. You definitely can understand that. Please make a note of that.
Completed, ma'am.
Yeah, all of you? Okay. Write down. All right. So these terms also we have come across last year. If the sector angle is less than 180 degrees, the sector is called a minor sector. If the sector angle is more than 180 degrees, the sector is called a major sector. And if it is equal to 180 degrees, it's a semicircular region. So here you see a minor sector. A minor sector looks like this. That is, if the sector angle is less than 180 degrees, this is how it looks like. If the sector angle is equal to 180 degrees, this is how the sector looks like. This is one radius. See, this is the radius. Because we know that a sector is a region bounded by two radii and one arc. So these are the two radii. From the center, radius, from the center, radius, and this is the arc. This is the arc. So the first one is a minor sector. The second one is a semicircular region. And the third one is a major sector. So if you call this one theta, if you call this angle theta, then the rest of it is 360 minus theta. Where the angle is 360 minus theta, that region is called the major sector. If we call angle AOB as theta, if angle AOB is theta, then the reflex of angle AOB, that is the rest of, see, this is the complete angle around O. This is the complete angle around O. So if this portion, if this angle is theta, the rest of it around O is 360 minus theta, which is the reflex angle, which is the reflex of angle AOB. So this region where the angle is 360 minus theta represents the major sector. That's how it looks like, a major sector. A minor sector looks like this. A major sector looks like this portion. And this is a semicircular region. Here also, this is the radius. Radius, radius, and arc. This is the arc. Okay, that's how we understand a sector. Bounded by two radii and an arc. And an arc. So the formula we've given here is, nothing is mentioned whether it is major or minor, but we normally assume this to be a minor sector. So the formula to find the area of a major sector, okay, area of major sector is equal to same thing. You should take the major sector angle, 360 minus theta. Area of the major sector will be some fraction of pi r square. So how do you find that fraction? The angle in the major sector is 360 minus theta. The angle in the major sector is 360 minus theta. That's the angle in the major sector divided by 360 into pi r square. Square units. Similarly, length of major arc. When we say arc here, no, length of arc ACB, it's the minor arc ACB. It's the minor arc ACB. So the length of major arc will be the angle in the major sector, the same thing, 360 minus theta. That arc is a part of a sector. This major arc is a part of the major sector. So whatever is the angle in the major sector, so 360 minus theta, that angle by 360 into 2 pi r units. And the perimeter. Perimeter of arc OACB. Okay, let me take D because you shouldn't get confused. I took C earlier for minor. So let me say D here. OADB. is equal to, that's a major arc. OADB is the major arc. OADB is the major arc. So perimeter of, sector. Perimeter of major sector. OADB is equal to the same thing, radius plus the length of the major arc. The length of the major arc, that is the length of the arc ADB. So it is again 2R plus L or diameter plus L. Or diameter plus L units. The perimeter of the major sector, OADB. The perimeter is basically the length of the boundary. It's the length of the boundary. So on the boundary, we have two line segments and one arc. So line segment OA, which is a radius, line segment OB, which is a radius, so R plus R, and then we have one arc. These three things cover up that sector region. So R plus the length of the arc ADB. So 2R plus L. L is the length of the major arc here. All right. Now, so this is, formally very formally the formulae used in this chapter, but you can look at the, figure in a different way also. We'll see that now. See here. Now, to find the, listen carefully. Have we finished writing this, children? Please write down and let me know. Yeah, done, children?
Yes, ma'am.
Okay. So now, supposing, we have found the area of the minor sector, okay? We have found the area of the minor sector. We just assume that we have found the area of the minor sector. Now, to find the area of the major sector, you can find the area of the circle. The area of the circle minus the area of the minor sector will give you the area of the major sector. The minor sector and the major sector put together make the complete circle. The minor sector, the major sector together is a circle. So supposing you found the area of the minor sector, area of this region, minor sector. Area of the circle minus the area of the minor sector will give you the area of the major sector. Similarly, if you found the area of the major sector, area of the circle minus the area of the major sector will give you the area of the minor sector. Or like the formula says, supposing the sector angle is 60 degrees, then the angle in the major sector will be 360 minus 60, 300 degrees. Going by the formula. If this angle is 60 degrees, the angle in the major sector will be 360 minus 60, 300 degrees. So 300 by 360 into pi r square is the formula to find the area of the major sector. So similarly, length of arc, length of arc, length of arc, this arc, the length of this arc, we know is theta by 360, theta by 360 into 2 pi r, because length of arc, no, so 2 into 2 pi r. So theta by 360 into 2 pi r will give you the length of this arc. Now the circumference of the circle, the total length, the circumference of the circle minus the length of the minor arc will give you the length of the major arc. Will give you the length of the major arc. Because this is the major arc, this is the minor arc. Together is the full circle. So it's like length of the minor arc plus the length of the major arc is equal to the length of the circle or the circumference or perimeter of the circle. So if you have found the length of the minor arc, this one, the length of the minor arc, the length of the circle minus the length of the minor arc will give you the length of the major arc. Okay. Or you can use the formula. The formula is, if this is theta, this is 360 minus theta. So if you want to find the corresponding arc, if you want to find the length of the corresponding arc here, this one, so then you should take this angle. If you want to find the angle and the arc go in the same direction. The angle and the arc, they go in the same direction. If you want to find the length of this arc, then you need to take this angle. See, you want to find the length of this arc, no? Then you need to take this angle. If you want to find the length of this arc, then you have to take the measure of this angle. You want to find the length of this arc, you need to take the measure of this angle. This is theta, so this one will be 360 minus theta. So now coming to segment. A segment is a region bounded by a chord and an arc. Again, in segments, we have major segment and minor segment, circle, chord. Now, this chord AB divides the circle into two portions. Each portion is called a segment. The portion which has the center of the circle is called the major segment. And that portion which does not have the center of the circle is called the minor segment. If the center lies on the chord, if the center lies on the chord AB, that is if the chord is the diameter, we know that the diameter is the longest chord in a circle. Diameter is the longest chord in a circle. If the center lies on the chord, then each region is called a semicircular region. Semicircular region. Like we saw in the case of a sector. If the sector angle is less than 180 degrees, minor sector. If the sector angle is more than 180 degrees, major sector. If the sector angle is equal to 180 degrees, then each region is called a semicircular region. Same thing here. Semicircular region is a situation where sector and segment coincide. Semicircular region can be looked at as both a sector and a segment. The semicircular region, you can look at it, or it will satisfy the definition of both a sector and a segment. We'll see that. So I was telling you, with respect to a chord, you can see the circle as a minor segment and a major segment. The segment that the region that contains the center is the major segment. The region that does not contain the center is the minor segment. And what is a segment? It's a region bounded by a chord and an arc. A chord and an arc. A chord and an arc. Chord, arc. So if this is the minor segment, then this is the minor arc. And if this is the major segment, this one is the major arc. Like a minor sector and a major sector. Minor sector contains the minor arc. Minor segment also contains a minor arc. Major sector, major segment contain the major arc. Now the question is, how do we find the area of the segments? Area of sector we understood. How do we find the area of the segments? Yeah, I was telling you that if the center lies on the chord, if the center lies on the chord, then each of these regions are called the semicircular regions. And a semicircular region is both a sector and a segment at the same time because it satisfies the definition of both sector and segment. Now, a sector is a region bounded by 2 radii and 1 arc. So you can see 2 radii and 1 arc. So this one is a sector. Also, a segment is a region bounded by a chord and an arc. So this is the chord because we know that the diameter is a chord. It's the longest chord of the circle. So this is the chord, this one together, meaning the 2 radii together is the chord. It's a diameter. So this is the chord and this is the arc. Segment is a region bounded by a chord and an arc. This is the chord, the diameter is the chord, and this is the arc. So it's also a segment. Semicircular region is both a segment and a sector at the same time because it satisfies the definition of a segment as well as a sector. So when do we have a semicircular region? In the case of a segment, when the center of the circle lies on the diameter or on the chord. And in the case of a sector, where the sector angle is equal to 180 degrees. In the case of a sector, when the sector angle is equal to 180 degrees. Okay. So how do we find the area of the segment? Now the segment, the sector actually is made up of 2 plane figures. The sector is made up of 2 plane figures. The sector has a triangle and it has a segment. The sector has a triangle and a segment. See, this is the sector. This is the sector. You can see that the sector is made up of 2 plane figures. It's the triangle and the segment put together. The triangle and the segment put together is the sector. So clearly, area of triangle plus the area of the segment is equal to the area of the sector, which means area of the segment is equal to area of the sector minus the area of the triangle. Because in the area of the sector, you have 2 things. the sectors, the area of the sector has the area of the triangle and the area of the segment in it. Area of sector has area of triangle and area of segment in it. So from the area of the sector, if you take away the area of the triangle, you will get the area of the segment. Okay. So we know how to find the area of the sector. Sector area, we know theta by 360 into pi r square. We know how to find the area of the sector. So we need to know how to find the area of the triangle associated with the sector. So if you can find the area of the triangle associated with the sector, the difference, area of sector minus the area of the triangle, will give you the area of the segment. So now we have to understand the different types of triangles we have in our syllabus. Okay, so coming to that. So I'll just write in general area of segment. Area of segment ACBD is equal to area of sector OACB minus area of triangle AOB. Area of the segment. The segment is a region bounded by the chord in the arc. So area of segment ACBD is equal to area of the sector OACB minus area of triangle OAB or AOB, whatever. So this is the general idea. Now, how do we find the area of the triangle? Now, we will be coming across only 3 cases. We'll be coming across only 3 cases. Case 1, when the sector angle is 60 degrees. Case 2, sector angle 90 degrees. Case 3, sector angle 120 degrees. What are we trying to understand now? We're trying to understand how to find the area of the triangles associated with the sector. So when we talk about triangles, you will have only these 3 situations. Either the sector angle is 60 degrees, or the sector angle is 90 degrees, or the sector angle is 120 degrees. Now, when the sector angle is 60 degrees, OAB is an equilateral triangle because OA is equal to OB. OA is equal to OB, radius. So that means this angle is equal to this angle. See, the sector angle is given 60 degrees. Now, this triangle is always an isosceles triangle. This triangle OAB is always isosceles because OA is equal to OB, radius. So this triangle OAB is always isosceles. OA is equal to OB, which means the base angles are always equal. Now, when the angle at the center is 60 degrees, the remaining remaining sum is 180 minus 60, 120. So these 2 angles have to share it equally. So 120 by 2, 60, 60. When the sector angle is 60 degrees, the remaining sum is 180 minus 60, which is 120. So these 2 angles are equal. So they have to share that sum equally, 120 by 2, so 60, 60. Which makes all the 3 angles 60 degrees, which means triangle OAB is equilateral. Okay. When theta is equal to 60 degrees, I'm just calling that central angle theta. Okay, when theta is equal to 60 degrees, triangle OAB is equilateral. Then how do you find the area of the triangle? Root 3 by 4 into a square. Root 3 by 4 into a square. We also have another formula, children. A half r squared sine theta. I'll come to that later. If you've learned that in school, I'll come to that later. So if it's an equilateral triangle, you know the formula to find its area is root 3 by 4 a squared, square units. We know this. Now when the sector angle is 90 degrees, when theta is equal to 90 degrees, when theta is 90 degrees, so we know that we can regard OA as the base and OB as the height. You can take this one as the base and this one as the height. Or the other way around, you can take OB as the base and you can take OB as the base and OA as the height. Because the right triangle, no? See, with the right triangle, we've always been doing that. If it's the right triangle, don't we take this as the base and this is the height? That is the sides containing the right angle. We take the sides containing the right angle as the base and height. So same thing here. The sides containing the right angle are OA and OB. So you can take one of them as the base and the other one as the height. So when theta is 90 degrees, area of triangle OAB, it's a right triangle. That is simple, right? When angle is 90 degrees, it's a right triangle. So area of triangle OAB is equal to half base into height. Half into base into height, which is half into radius into radius. Half into radius, right? Because OA is R, OB is also R. Half into OA into OB. So which is half into R into R, which is half R square units. When theta is 60, see the triangle is always isosceles because OA, OB radius, obviously they're equal. So in the triangle, two sides are always equal. So it is isosceles. When the sector angle is 60 degrees, it makes the triangle equilateral. So the formula to find the area is root 3 by 4 a square. When the sector angle is 90 degrees, it's a right triangle. And we've always been using the formula half base into height to find the area of a right triangle. And we have to take the sides containing the right angle as the base and height. The sides containing the right angle should be taken as the base and height, not the hypotenuse. The hypotenuse AB should not be taken as the base or the height. So it is half OA into OB, half into R, radius into radius, so half radius square is area of the triangle. In this case, where the sector angle is 120 degrees. Okay, so it's an obtuse triangle. The angle at the center is obtuse. So OAB is an obtuse triangle. Here it is acute. Here it is acute and it's equilateral. This one is a right triangle. This one is an obtuse triangle. In the first case, it's acute and it is equilateral. So when the sector angle is 120 degrees, area of triangle AOB is equal to half R squared sine theta. Square units. There is the derivation for this, and I have been doing that in the past, but now the syllabus is diluted and yeah, so I'm not just doing it. Half R squared sine theta.
Ma'am, could you please show the previous slide for a second?
Yeah.
Thank you, ma'am.
Yeah. So when theta is 120 degrees, it's an obtuse triangle, and the area of triangle AOB is equal to half R squared sine theta. Half into R square, you know, R is the radius. Sine theta. Theta is a angle at the center. Sine theta. Theta is 120 degrees. So how do you take the value of sine 120? So if it is not given to you, so sometimes it's not given. The sine of 120 degrees is not given to you. How many of you have learned this chapter in school? Shashank, huh? Okay. So in that case, so you can use this if you have the value of sine theta given to you, sine 120. Otherwise, you can use the formula r squared sine theta by 2 cos theta by 2. And write that also. Or area of triangle AOB is equal to r squared sine theta by 2 cos theta by 2. You can use this formula. Square units. Square units. You can use this formula for all the triangles, but you need to understand, like what kind of triangles they are for different sector angles. Okay, you can use, this is universal, r square sine theta by 2 cos theta by 2. You can use for anything, meaning when the sector angle is 60 degrees, 90 degrees, universally you can use it. It's not that you have to use this only when the sector angle is 120 degrees. Not like that. You can use r square sine theta by 2 cos theta by 2 when the sector angle is 60 degrees, 90 degrees, and of course 120 degrees. For all the three, you can use this formula. It'll work to the same thing. No difference in answer. You'll get exactly the same answer. So area of triangle AOB is equal to r square, that is radius square, sine theta by 2, that is 120 by 2. Sine theta by 2. Theta is 120. 120 by 2, 60 degrees. So sine 60 degrees, cos 120 by 2, 60 degrees. So cos 60 degrees. So the formula is nothing but r square sine 60 degrees, cos 60 degrees. Sine 120 by 2, cos 120 by 2. R squared sine 60 degrees, cos 60 degrees. Make a note of all this, children. Done writing, children? Done writing, children?
Yes, ma'am.
Yeah. Okay. So now you just have to put it in this formula. You know that to find the area of the segment, it is the area of the sector minus the area of the triangle. So you know how to find the area of the sector. And now we also know how to find the area of the triangle. The difference will give you the area of the segment. The difference will give you the area of the segment. And once you find the area of the minor segment, once you find the area of the minor segment, the area of the circle minus the area of the minor segment will give you the area of the major segment. Once you find the area of the minor segment, the area of the circle minus the area of the minor segment will give you the area of the major segment. So area of major segment is equal to area of circle minus area of minor segment. Area of the major segment is equal to area of the circle minus area of the minor segment. Done, children?
Yes, ma'am.
Okay. So now what is the, let's just understand what the major segment is made up of. What the major segment is made up of. The major segment, if you notice, major segment, see here, this is the chord. The major segment, if you notice, is made up of the triangle, and the major sector is made up of the triangle and the major sector. Just watch that. The major segment, this one, this major segment has two things inside it. It has the triangle, and the major sector. This is the major sector. This one is a sector because two radii and an arc. This one is a sector. And this is the triangle. The sector, the major sector and the triangle put together makes the major segment. I'll draw it again. This one is the major segment. This one is the major segment. Try to draw it more neatly. So this is the chord. This is the chord AB, and this is the major arc. And this is the major segment because it's bounded by the chord AB and the major arc. So this is the major segment. Now in the major segment, we'll have the triangle. And we have this major sector. We have the major sector. So the major segment is made up of two plane figures, triangle and the major sector. So if you want to find the area of the major segment, you can also do this. If you want to find the area of the major segment, one is what you see above. Area of the major segment is the area of the circle minus the area of the minor segment. You can also find its area like this. The area of the major segment is equal to area of the triangle plus the area of the major sector. These two put together because these two make the major segment. So the area of the major sector plus the area of the triangle will also give you the area of the major segment. Am I clear, children?
Yes, ma'am.
Okay. The major sector and the triangle together make the major segment. So you can also find the area like this. You can find the area of the, if you have the area of the triangle and if you have the area of the major sector, simply add the two, you will get the area of the major segment. You don't have to find it separately. MCQs. They'll give you the area of the triangle and the area of the major sector. And they'll ask you to find the area of the major segment. So if you know this, you just have to add and find the area of the major segment, which is why we have to discuss all this. All right. Now remember this very important formula. Again, children, derivations we are not talking about. Just remember this as a formula. Area of sector is equal to LR by 2. It's actually half LR, but this one is easy to remember, I think. LR by 2. LR by 2. Or you can say half LR. Both are the same. Half LR or LR by 2. So I have not mentioned if it is the minor sector or major sector. If it is the minor sector, L is the length of the, 1 second, children. Yeah, thank you. Remember that area of the sector can also be, excuse me, can also be found using the formula LR by 2 square units. Where L is the length of arc, that arc which is associated with the sector. So if it is the minor sector, the length of the minor arc. If you're finding the area of the major sector, you should take the length of the major arc. If you're finding the area of the minor sector, if you're finding the area of the sector, sector is of two types, no? Major, minor. If you're finding the area of this sector, that is the minor sector, it will be L into R by 2. R is radius, that is the same for the circle, by 2. 2 is a constant. So nothing about R by 2, nothing to worry about R by 2. Now this L, if you're finding the area of the minor sector, a sector which looks like this, then you should take the length of the minor arc. This one, this is L. This is the length of arc. L is the length of the arc, which is associated with the sector. L meaning this L, length of arc, into radius by 2. If you're finding the area of the major sector, this one, this is the major sector. Then it is the length of the major arc. It's the length of the major arc. It's the length of the major arc, this one, L, this L, into R by 2. Got it, children? Again, 1 mark this is. They'll give you the length of arc. They'll give you the length of the minor arc. L actually is the same length of minor arc, length of major arc, both normally represented by small letter L. Now don't get confused. Don't have this question in your mind as if L is the length of the minor arc or the major arc. It will be clear. There'll be no confusion. It will be given very clearly. So L is the small letter L is used to represent the length of the minor arc as well as the major arc. So if you take the length of this arc, this is the length of the minor arc, into R by 2 will give you the area of this sector. If you take the length of this arc, the major arc, into R by 2 will give you the area of the major sector. Very important formula. Area of sector is equal to LR by 2 square units. Area, so square units. Got it? Done writing, children?
Yes, ma'am.
Okay. So that's about the introduction to this chapter.
Once again, can you go back, ma'am?
Sure, sure.
Yes, ma'am.
Yeah. Okay. Don't write anything. Just listen to me. Now, this is a triangular field and the sides are okay. So this is a triangular field, children. All right. Now, 3 animals are tied to the, this is a triangular field. Okay. 3 animals are tied to the 3 corners, to the 3 vertices of this field. Say a cow, a buffalo, and a goat. Okay. So they are tied to the 3 corners of this field using a rope which is 7 meters long. So a rope which is 7 meters long is tied to this vertex. So this is the maximum length of the rope, 7 meters, right? The length of the rope is 7 meters. So this is the maximum length of the rope, say 7 meters. And the animal can maximum move like this. Because imagine, something. So, okay, so supposing there's a pole and like put your arm, your hand on the pole and you want to go around it. You will be tracing the shape of a circle. If there's a pole and you hold the pole and go around the pole, keeping your hand fully stretched. Keeping your hand fully stretched. So keeping your hand fully stretched, you're holding the pole. You keep your arm fully stretched and you go around the pole. You will be tracing the shape of a circle. In the same way, this animal, which is tied here, if it keeps its, rope tight, that is taut, and if it goes around, if it tries to move, this is the maximum, length, or this is the maximum boundary it can trace. It cannot go beyond that. So this is the portion. This is the portion that is used by the animal tied to this corner. In the same way, the length of the rope here also is 7 meters. Here also it is 7 meters. So the maximum area that can be traced by this animal is this region. Because if it goes around it, it can't come outside. No, it's a field. It can't come outside. It's a field. It's a triangular field. It cannot come outside the field. Probably there's a compound wall or whatever. It cannot go outside the field. If it were open, then it will trace a circle like this. Inside the field, it will trace this one, which is a sector. And the third animal tied to this corner, the length of the rope is again 7 meters. And the maximum portion it can reach is this one, when the rope is fully tight. So this sector represents the entire area this animal can reach. The animal at corner A can reach. And the animal at corner B can use this area entirely. And the animal at corner C can use this area entirely. And supposing there were grass here, there were grass here. So the maximum area this animal at corner A can graze is this one, the area of this sector. Similarly, the area of this sector is the area the animal at corner B can graze maximum. And the same thing here, the animal at C, the maximum area it can graze is this area. All the three are sectors. All the three regions are sectors. And the sector angles, angle A is the sector angle for this sector. Angle B is the sector angle for this sector. And angle C is the sector angle for this sector. See, at A, we have a sector like this, right? This is a sector. So this is the sector angle. Angle A is a sector angle. Similarly, angle B is a sector angle. Angle C is a sector angle. So the area of the field that can be grazed, I told you, if there is grass, supposing the entire field, the grass is grown on the entire field, the maximum area of the grass that can be grazed by the animal tied at corner A will be the area of the sector. And the area of the sector is angle A by 360 into pi r square. Angle A by 360, because theta, what is theta? The sector angle. And what is the angle? Angle A by 360 into pi r square plus area of sector B is angle B by 360 into pi r square plus angle C by 360 into pi r square. We are not given the measures of angle A, B, and C. We are not given. Now here in this expression, or we have written an expression to find the area of the three sectors together. Add, no? Okay, so angle A by 360 into pi r square plus angle B by 360 into pi r square plus angle C by 360 into pi r square will give you the area of all the three sectors. Separately, you cannot find the area of the sectors because we don't know the sector angle. If you don't know the sector angle, you cannot find the area of the sectors separately. So now what's common here? Pi r square by 360 is common. Pi r square by 360 is common. So in bracket, you'll have angle A plus angle B plus angle C. You can see in all these three expressions, this expression, and this expression, pi r square by 360 is common. So in the bracket, you will have angle A plus angle B plus angle C. What is angle A plus angle B plus angle C? 180 degrees. The sum of the three angles of a triangle is equal to 180 degrees. So we don't know the angles individually, but we know that the sum is 180. So it will become pi r square by 360 into 180. Into 180. So 180 ones are 182s are. So pi r square by 2. Pi r square by 2. So you have to substitute the values. The value of r is 7. The value of r is 7 is given. The length of the rope is 7 meters. So the value of r is 7. Pi 22 by 7. So on substituting the values, you can find the area of the three sectors. Now to find the area of the triangle, you can use Heron's formula because you know the lengths of all the three sides. To find the area of the triangle ABC, you can use Heron's formula. 20, 30, 42, you'll have to find the semi-perimeter. S is equal to A plus B plus C by 2. Find the semi-perimeter, and then the area of the triangle is square root of S into S minus A into S minus B into S minus C. So this formula will help you to find the area of the triangle. Now, if the question is, what is the area of the field ungraced? That is, which cannot be reached by the three animals. What is the area of the field that is ungraced? Will be the area of the triangle, which you have found using Heron's formula, minus the area of the three sectors, which you can find using pi r square by 2. Pi r square by 2 is the area that can be grazed, that is grazed, that can be maximum grazed by the three animals. Area of the triangle minus the area of the sectors that can be grazed will give you the area of the region, area of the field that is ungrazed. So I just explained the situation for you. If you have to find the area of the field that is ungrazed, you have to find the area of the triangle using Heron's formula. We cannot find the area of the sectors separately because we do not know the sector angle. But we can find the sum of the areas of the three sectors. So we find that, and the difference will give you the area ungrazed. Is that clear, children?
Yes, ma'am.
All right. Online children, use the emoji, raise your hand. When I started the meeting, I did not see Krishmi, Dileepan, and Arjun. Arjun, were you very late in joining?
By 7:45 only I joined. By 7:45 only I joined.
Okay. Why?
I'm in my grandmother's home. I had some problem with my network.
Okay. Okay, now lower your hands, children. And how many of you have learned this chapter already in school? Raise your hand. Lower your hands, all of you. Yeah. Madhum, who's learned? Sashank, is it? Okay. Oh, Sashank and Madhumita. Okay. Okay, Sashank and Madhumita have learned this in school. Okay, Dadi. The others, have you understood clearly? Prajit, Rakshita, Dileepan, Krishmi, and Arjun?
No,
Yes,
ma'am.
ma'am.
You have some doubt, Rajat?
I have no doubts.
Oh, okay. All right, clear. Is this situation understood, children?
Yes, ma'am.
All right. Now we'll just extend this to a quadrangular field. We'll just extend this field to a quadrangular field. Okay, not a triangular field, a quadrangular field. Same situation, four animals. Four animals are tied to the four corners of a quadrangular field. That is a field in the shape of a quadrilateral. The length of the rope used is the same. If they are different, again, you cannot find. The length of the rope used to tie the four animals to the corners is the same. The length of the rope is the same. Whatever, 7 meters, 14 meters, whatever. The length of the rope is the same. So if I call this quadrangular field PQRS, angle P by 360 into pi r square is what? What is angle P by 360 into pi r square? The area of this sector plus angle Q by 360 into pi r square will be the area of this sector plus angle R by 360 into pi r square will be the area of this sector plus angle S by 360 into pi r square will be the area of this sector. So as we did earlier, we take pi r square by 360 common, and in bracket we'll have angle P plus angle Q plus angle R plus angle S. And we know that the sum of the four angles is 360 degrees, not 180, 360. So gets cancelled. So pi r square. So pi r square will give you the sum of the areas of the four sectors. So if you have to answer the same situation, find the area of the field ungrazed. So you have to find the area of the quadrilateral or the area of the quadrangular field. Find the area of the quadrangular field. So now your question is how do you find? So it will be given, that is the field is in the shape of a trapezium. Then you should know the formula to find the area of a trapezium. So details will be given for you to find the area of the quadrangular field. Mostly it is a trapezium. If it is not a trapezium, they'll give you the area of the field directly. Whatever. So you will be given information to find the area of the quadrilateral. If it is not a special quadrilateral and if it is not possible to find the area, they'll give you the area value straight away. If the trapezium, you should know how to find the area. Half sum of the parallel sides into distance between them. You should find the area. If the trapezium. So area of the trapezium. So if it's area is given to you, or if it's a trapezium, you can find the area. So area of the quadrilateral or the quadrangular field minus the area of the four sectors will be the area of the field ungrazed by the animals. Is that fine, children?
Yes, ma'am.
All right, children. So that's about the introduction to this chapter. We'll continue with this chapter in the next class. Now I'm going to share another link with you where we'll be revising statistics. So I'll share them 1 second. I'll just share the link. All of you just make sure that you receive it. Yeah. So I've shared another link on WhatsApp. Leave this meeting and join the meeting using the other link or join the other meeting. All right. All right, children. Thank you. See you in the next meeting.
Thank you, ma'am.
Thank
Thank
you.
you, ma'am.
Thank you, children.
Thank you, ma'am.